Nitesh Pradhan from LabVIEW and Multisim. It is our 11th number video of LabVIEW tutorial. In this video, we will discuss about finite loop programming. It means we will discuss about the for loop. Finite loop is a repetitive class model where we can repeat our same logic and program n number of time. Here the n number of time is called finite. You can select the value n. So let's start today's session. Come into the LabVIEW and open it. Now you can see the left side background is my front, the left side window is my front panel and the right side window is my block diagram. Now here I am going to customize my window first. So for that I will come into the tools. In the tools you will get the option in the last. Click on the option. After that come into the environment. Come into the front panel first. In the front panel, here I am going to select the control style for new VI and XG style. Now here I am going to disable the grid option, front panel grid. After that, come into the block diagram. I am going to select the place front panel terminal as an icon. Close. Now here I am going to control palette. In this control palette, okay, everything is same. I know there is no need to change. I am not going to change anything. Then environment. In the environment, come here, come down. Then you will get the color. Open the color. I am going to select the front panel white. Then I am going to press the OK button. Now again open it. When you will again launch your LabVIEW and open, so you will get your front panel and block diagram with the same color. Okay. Now right click in the front panel, pin in the toolbar, come into the option, customize. In the customize, change visual palette. Using this change visual palette, you have to deselect all and then select only the next generation NXG style. Press OK. Now you can see I am easily able to customize my front panel and block diagram as per my own required color. Now here I am going to change the front panel color to the proper white. Press OK. Open. Again press Ctrl N, Ctrl T. Okay. Now let's come into the block diagram and let's try to search the for loop. In the programming language, if you are writing one program, like here I am taking this random number program, and when I will take indicator, I will create an indicator, so I will get the same random number 0 to 1. Now here I am going to run the program. Because here I didn't apply any kind of the loop, that's why my this VI will run only once. Whenever I will press Ctrl R, either I will press this button, so this VI will execute only once and I will get only single data. But what happens if I want to run this program, this VI for 10 times? I want to iterate my program 10 times. So for that I can use for loop. So let's search the for loop. Right click on the block diagram. When you will right click on the block diagram, you will get a function palette. In this function palette, you will get this structure. In this structure, you will get this for loop. Now take the for loop and place here. Place it on the block diagram. So you will get a for loop like this. Then drag and increase the size. It is my for loop. So how can we take the for loop? Right click on the block diagram. The first is the function palette. In the programming section, structure, take a for loop, place it here and drag and increase the size. Now here I am going to press the Ctrl H. Ctrl H will give me a brief information about for loop. For loop executes its subdiagram n time, where n is a value y to the count terminal n. The iteration I terminal provide the current loop iteration count, which range will 0 to n minus 1. It means if you want to run any logic inside this while loop, suppose I am taking the same program here. Random number generator, same program here I have taken. Now, if I want to run this program n number of time, so I have to give one value to the n. So for that you can right click here and you have to create constant. Now in this create constant, you can put any value. Okay, you cannot write any negative value here. In place of negative, you can write any other number. Okay, so let's go ahead. Now you can see if I will run the program, due to the speed up the execution, it will not show you the each and every 10 iteration. So for that, now you can see here I am going to press the execution highlight and now run. Now you can see here this loop will run 10 times. This loop will execute 10 times. Now my program is running. This VI is running only once. During this once, the loop will execute 10 times. One of the most important things here, whenever you will use the for loop or while loop, don't press this run continue button. Only press the run button. Now you can see here this for loop is iterating 10 times. Let's take an indicator for this I. This for loop will run 10 times and each and every time I will this I terminal will give other iteration value, and the iteration value will be start from 0 and it will be end from the n minus 1. That means the I will generate number from 0 to 9. Let's check again. First iteration 0, second iteration 1, third iteration 2, fourth 3, fifth iteration 4, sixth iteration 5, seventh iteration 6, eighth iteration 7, ninth iteration 8, and 10th final iteration 9. That means my for loop is running 10 times, and each and every time my random number generator is generating one value and it's displaying that value by the indicator, numeric indicator. Numbers 201 indicator, that is a numeric indicator. And below there is one more numeric indicator is present, but that is a okay that is connected with the n, that is connected with the I. So I is generating value 0 to 1. The below numeric, this numeric is my integer type and it is my DBL type. And now you can see here my random number generator and my I are generating the value, and it's we can easily able to read each and every value, but we cannot able to store the value for a long time because my both indicators are overwriting with the each and every execution. So how can I display and how can I record my all the data? So for that we have to create an array. So for that we have to create an array. Now right click, come here. Okay, okay. Later we will work. No need. Because before going to that, I have to explain about the shift register. So now, the one of the best and easiest method is click this wire and pass the wire through this boundary. Now indicator is present inside the loop. That's why we are able to read each and every value, but every time it's overwriting. So I am thinking, how can I display and record all the data? So for that, click here and try to pass the wire through the boundary. Whenever you will try to pass the wire through the boundary, you will find this kind of the tunnel. This kind of tunnel. So this tunnel is auto index tunnel. The tunnel name is auto index tunnel, and this tunnel will create a array for our data. The array for our data. Right, same here. If I will try to create a indicator for this tunnel, so I will get one more array for the below data. Now you can see here the array 1 data. The array 1 is a numeric array indicator and array 2 is also a numeric array indicator, but numeric array data type is DBL and array data type is DBL and array 2 data type is integer. Now you can expand the array size by dragging. Now you can expand the array size by dragging. Here, when I will try to run the program, when I will run this program, now you can see here my random number generator and my I both are generating the value. My numeric and numeric 201 indicator are displaying the same value each and every time. You can see on the front panel, but you will not get any data on the array. When the loop will stop the iteration or loop will complete the execution, then you will get all the data at the once. You can take your time and you can check the program. Look at here. Again, I am going to run the program. Each and every iteration, random number and numeric are generating some value, and we can easily able to see and display that value using the numeric indicator or number 0 to 1. But we are not getting any data on the array and array 2. We will get data only when loop will complete the execution. That means in this auto index tunnel, there is some buffer elements, some memory are available. Okay, due to this memory, okay, this auto index tunnel can store the array value. Now let's go to the another example. Right click, take a for loop and place here, create control, value 10. Here my random number generator will generate, here the random number generator will generate the number between 0 and 1, number between 0 and 1. By creating indicator, I can easily see that value or display the value, right? And we know very well, if we will pass a wire through the border, so it will create a auto index tunnel, and due to auto index tunnel, it will create a array. It is clear to all of us. This one more beautiful thing is here. If I will create a indicate, if I will try to pass the wire through the array, through the border, so definitely it will create a auto index tunnel. But suppose if I want to get only last value data, I want to run my program 10 times, and after 10 times I want to read only last value data. I'm not interested to read other data. I only want to read the last value. So for that, we have to right click on this tunnel. You have to click the tunnel properly. Then you have to right click. You will get tunnel mode, and then you have to select the last value. You have to select last value. Now you can see here my loop is iterating continuously, and each and every iteration random number generator is generating the value, and I am getting the data number 201 which is present inside. But when the loop will complete the iteration, we will get the number on number 201, the outer one. Right? So it is last value. So how can we get the last value? By right clicking, click, come into tunnel mode, last value. Here I want to explain. Let's come into the third concept, and the concept is if we can generate if we can generate a 1D array, if we can create a 1D array using one for loop, so using two for loop we can create a 2D array. Let's see. This auto index tunnel will create a 1D array, and this auto index tunnel will create 2D array. Using two for loop we can create two dimensions array. Now let's see. When this outer for loop will run first time, this second for loop will run fourth time. The outer for loop will run first time, so the inner one will run fourth time. That's why in the first iteration it will generate 0, and it will take that 0 four times. It will take that 0 inside, and this loop will run 4 times, and that's why it will generate 4 0. That you can see on the first row. In the second row, when it will generate 1, it will again run 4 times, and every time it will generate a 1. That's why we are getting the 4 1 on the second row. This outer loop will run 5 times, and this inner loop run totally 20 times. It will run 5 times and it will run 20 times. Let's try to write an example. Right click, create control. Right click, come here, take a multiply functions. Open the label. Connect the multiply button with this because it will generate value 0 to 9. Now come here and take a numbers, table number. And create an indicator. Using this program, using this example, you can create table for any number. Now here I am going to change. I am going to enter the value 2. So you can see here you can generate a table for 2. But there is one problem. There is a one single challenge, one single problem. And problem is generating the table from 0 to 18. It's not generating the table from 0 to 10, 0 to 20. Why? Because each and every time, each and every iteration, it will generate one value, and the number will start from the 0 and it will go to the 9. And each and every iteration, this number 2 will multiply with the value of I. Suppose it's 2 multiplied by 0, 2 multiplied by 1, 2 multiplied by 4, 2 multiplied by 8, 2 multiplied by 9. That's why we'll get the value 0 to 18. So how can I change these iteration numbers? So for that, right click, come here, take increment. Using this increment functions, we can increase our value or we can change the initial value. Now control R. Now you can see here, using this way I can easily create a table for 2. In place of 2 you can write any numbers, minus 7.91, and you can create table for minus 7.91. Now coming to the another example, come here. For loop, take one more for loop. Create constant 10. Now connect your for loop like this. Now come here, right click, come into the numeric data type, take a increment functions, place here, take it inside like this. Right click, take a numeric data type, increment, and multiply. Now multiply. Using this way, you can create a table for 1 to 10. Now you can see here, you are able to create a table for 1 to 10. Now, the outer loop will run only 10 times and inner loop will run 100 times. When it will generate 0, so it will convert 0 to 1, and when it will come inside, at that time this loop will run 10 times and it will generate a table for 0 to 10. Sorry, table from 0 to 10. Yes, sorry, 1 to 10. Look at here, 1 to 10, first row. So in the second time, when it will generate 1, it will convert 1 into the 2, and when the 2 will come inside, it will run again 10 times and it will generate 2 to 20. Same task it will perform for each and every numbers, and it will create a table for your given number or this. So you can say the outer loop is number generator and the inner loop is multiplier. Now, as I said, a for loop can convert your element, normal element, into the array. If you will pass any data outside from inside, so at that time it will create an array for your given number. It's clear this loop will run 10 times and each and every time it will generate some value, and that value we can display or store on this array. This automatic tunnel will save all the data, and when the loop will terminate, it will pass that data to the indicator and indicator will display the value, right? That means you can see here this I will generate a element, single element. This I will generate a single element, and this auto index tunnel will store all the elements. This auto index tunnel will store all the elements, and When the loop will stop execution, at that time it will pass all the data. So the array is not making any data. Okay, array is only displaying the data collection. Array is taking part to display the collected data. This auto index tunnel is making that data collection process. This auto index tunnel is doing the data collection process. So suppose if I have one small array, numeric array. I have this numeric array and I am going to put the value 98, 2, 6, sorry 5, 41, sorry 51, 22. Suppose I have these 5 numbers. Suppose I have this 5 number. And if I will connect this array to this for loop. Suppose we have this array with the 5 elements and I am connecting that array with this for loop from the left side. Okay. From the left side, then what will happen? If you are thinking, okay, let's create an indicator first. Now tell me what kind of number or which number you will get. Again, I am going to explain. This loop will run 10 times. Each and every time I will, okay, each and every time I will generate one value and that value will stored in the auto index tunnel, and when the loop will complete the execution, uh, then array will display each and every value. Now suppose we have one another array with this 5 element and we are connecting this array, we are connecting this array to the for loop by from the left side. So it's again generating a auto index tunnel. It's again generating a auto index tunnel, but you can say it is auto de-indexing. Auto de-indexing. So what value we will get? Let's see. So if I will run the program, so this auto index tunnel will read all the value once. The auto index tunnel will read all the value once. ये एक ही बार सारे डेटा को रीड कर लेगा. It will read all the value once and then it will generate single value. Then it will generate a single value and you will able to read each and every value. Look at here. It's read all the 5 value 92, 2, 5, 51, 22. And this loop will run only 5 times. This loop will run only 5 times. No matters I had given the value 10 to n, but loop will run 5 times because here the array the array is connected with the for loop and the size of array is less than n. Here the size of array is less than n. We have directly given the n is equal to 10, but the array which I had connected, okay, the array which I had connected, okay, so the array which I had connected, the size of that array is 5. That's why this loop will run 5 times and each and every time it will display each and every value, single value. First it will display 9, then 2, then 5, then 51, then 22. This loop will run only one. Sorry, this tunnel will read all the data only one, and it will store all the data inside the memory. When I will run the program, before the execution of program, this auto index tunnel will read all the value and it will store the value. And during the execution, it will display each and every value one by one, and the loop will run only 5 times, because here the n will select the lowest indexing, and the lowest indexing will be 5. Okay, now come here. One more example. Let's come into the one more example. One more concepts. Okay, let's come into the one more concepts, and the concept is shift register. Shift register is a very beautiful and strong concept for the for and while loop. Now you know very well this loop will run 2 times. This loop will run 2 times, and each and every time I will generate one value. I will generate one value, and it will generate there only two values, 0 and 1. When the loop will iterate first time, it will generate 0, and when the loop will iterate second time, it will generate 1. When the loop will iterate first time, it will generate 0, and the loop will iterate second time, it will generate 1. I can read only one item, I can read only one information, one value each iteration. Using this logic, I cannot read the previous iteration. Suppose in the first iteration I am generating one data, and I want to evaluate, or I want to analysis the second data along with the first data. So what can I do? So for that we can use the program recursion concept. That is for shift register in LabVIEW. Right click on the block diagram, come into the shift register and click. Right click on the block diagram, right click on the border of the for loop, right click on the border of the for loop, right click on the border of the for loop, and click on the add shift register. Right click again on the border of the for loop and add click shift register. Now here I am going to change the value, it's 10. Loop will run 10 times. Here I am going to connect the shift register like this. Now the shift register color is black, so the data type is not defined here. The data type is not defined here. Now when I will connect any data type, okay, shift register will work with the numeric, boolean, string, waveform graph, array, cluster. Okay, using the shift register, you can control any kind of data types. Here I am going to connect an integers. So now you can see automatically you will find the color has been changed. If I will try to create anything, create indicators or create anything, so I will not get any option to create any kind of indicators or any functions. Why? Because the shift register is now empty and the data type is not defined. Using this, I am going to define the shift register. Now create indicator and create indicator 2. Numeric indicator 2, this numeric indicator 2 will display the current iteration, and this numeric indicator will display the last iteration data. This numeric indicator will display the current iteration data. Current iteration means, suppose in the iteration number 4, I is generating value 3. So it will display the third iteration data 2. Suppose we are in fourth iteration. So fourth iteration I value will be 3. So here it will display the third iteration data. The data will be 2. You can examine here. You have to only check the numeric and numeric 2. Numeric 2 will display always a current value, and numeric will display the last iteration value. And the last, when the numeric 2 will display the value 9, the numeric will display the value 8 only. Okay, so let's use this concept. I'm going to write a program to add up n numbers. Here I'm going to create a control, and let's take addition functions. Right click, come here, take a shift register. If you will try to create an indicator, try to connect, so you can easily connect. Create constant. Now it's addition of n number. Create indicator. Here I am going to put the input n value, input n value, and sum of n numbers. Sum of n number. Sum of n number. Suppose here I am going to put the value 10. So loop will run 10 times, and I will get the sum of number 0 to 9. So it is not a perfect sum of n number. There is only one change is required, and the change is I have to remove first this one, then come here, take a increment functions, place here, and now make a connection. Now the program is ready, but before going to that, we have to initialize these things. Right click, create constant. We have to initialize these things. Now if I will run the program, so I will get the sum of n number. Sum of n number. So you know the sum of n number is 55. Sum of 10 numbers 0 to 10. If you have the number 1 to 10, so sum of that n number 10 number is the 5. If I will remove this one, if I will remove this 0, and if I will try to run the program, so in the first time I will get the value 0 to 10. The first I will get the value, the sum of n number is 55. Second time we will get 10, 1 0 10. Yes, 110. Why? Now you can see here, it's starting the value from 110. It's starting the value from 110. That means we are Okay, we are getting the last value last iteration some number as a initial number for our this example. So to avoid this kind of problem, we have to initialize. Now my program will start from the value 0 and every time I will get a fixed value. Okay, let's go to the one more concepts, and that is stack shift register. Come here, take a for loop, create constant, give the value 10, right click, take add shift registers. Now you know very well, if I will create an indicator, if I will create an indicator, so this I will generate, first create an indicator here, then create an indicator here. If I will create an indicator, second indicator, so now you can see here the numeric indicator 2 will generate the last value data. I think it's clear to all of you. Then again you can drag it like this. When you will drag it, so you will get one more shift register, so it will give you the second last data. If you will drag it third time, so it will give you the third last data. It will give you the third last data. Now run the program and you can easily check it to. And the last one, it will be the last value will 9, so the 9876, 9 the last value, 9 the current value, last value is 8, second last value is 7, third last value is 6. In this way you can call your previous iteration data into the current iteration, either you can transfer your previous current data into the next iteration. If you want to transfer your current data into the future iteration, so you can easily transfer using the shift register. Either you want to call your data from the past iteration, so you can easily call your data from the past iteration. Okay, let's create a waveform graph. Let's create a waveform graph using for loop. Right click, come here, take a for loop and come. Create constant 100. Right click here, come into the mathematics, take a divide functions, create constant 10 and divide this value, okay, to I. Now I is divided by 10. Create, come into the front panel, take a waveform graph and take a waveform chart. After that, right click, Right click on the block diagram, come into the mathematics, elementary, trigonometry, sine. Now run. Now you can see here we are easily able to plot our array, or we can easily able to plot our array data into the waveform chart. Suppose you want to make a graph and chart, so you can use the for loop and you can create that finite data. This for loop will run 10 times. I will generate value 0 to 99 and it will divide that value 0 okay by 10. Whatever the value it will generate, it will convert that value into the sine value and then you will get this. Okay, then you can create this auto index tunnel. Auto index tunnel will store all the data, and when the execution will stop, it will display it will display each and every value in a waveform chart. Right click, come here and take a for loop. You know very well, if I will give a value here, create constant, create control. If I will give a value, if I will give value 10, so loop will run 10 times. But if I will give value 0, if I will give value 0, so loop will not execute. So loop will not execute. Loop will not execute and loop will not. So now you can see here the numeric value is not changing because I am giving the value 0. Suppose if I will try to give the value -1, so also loop will not execute. So always value should be greater than 2. Greater than 2. If you want to use your for loop, so also value should be greater than 2. Either the if you will give the value is equal to 1, so that is no use. No need to use the logic, no need to waste the memory. Line of code, no need to extra write. So 2 and greater than 2. For 2 and greater than 2, you can use the for loop. So thank you for watching this video. For loop related video I will make more. One more video I will make where we will explain the various kind of examples and logic. So thank you for watching this video.